Okay, we're back. New YouTube video. First video in almost 2 months. The last time I recorded a YouTube video and uploaded it was August 2nd. I checked earlier today. But we're back recording. Not really much else to say other than that. I have been live streaming recently in case you are not aware. I made an announcement like in August or September saying over this semester I kind of want to live stream more instead of recording videos because the whole editing process takes a little bit. But I have been live streaming. This video is going to basically be a review of the past 3 live streams I've done, and those have been building on my most recent videos project, the linear algebra programming language in Rust. So, I mean, that's pretty much it. I actually live streamed this morning at like 8:30 in the morning. I didn't really have much else to do. But that, I have to edit it just because like there were some parts where I was just like not speaking for a while. So I got to edit that out, trim it up, and then I'll put it back up. So if you want to see how I wrote this like live, you can go watch the live streams. They are up. The previous 2 ones are up. The one from today should be up like this weekend. But this is going to be more of a developer log and explaining what I've done with the programming language I'm making. So I guess we could just get right into it. So in case, I'll go through everything fairly well. The last video went over the entire parser pretty much. I don't think I've done any work on the parser since then. But anyway, so when I run cargo run and I build this project, eventually I will just be able to run the executable, and I'll do something like lala and then the name of the file that I want, similar to how if you have a JavaScript file, you would do node, whatever, or a Python file, you would do Python 3, whatever. Right now, though, I just have it set to this file, matrix.lala. I guess we can just get right into this. Let me just make this a 3x3 matrix real quick. That's good enough. Okay, so this is going to read in a file called matrix.lala, which is like this. Reads it in as a string. And then it's going to pass that string into my parser. I'm just going to parse it and then give me back the AST. Now, if I go here and I do cargo run, as we can see, this big mess up here is the actual abstract syntax tree. And then this is the results of stuff that I was doing, which I'll show you in a few moments. This file isn't really an abstract syntax tree. It's really just like it's like a straight line, really. It's a list, pretty much. I don't have any branching, right? I don't have any loops. If I had if statements, if I had loops, sure, I could see this becoming more of a, abstract syntax tree. But right now it's like a stick. It's like an abstract syntax stick. I don't really know. I don't think that would have a good acronym like AST if I'd make it abstract syntax stick. But so this, right, I make 2 matrices, 3x3 matrices, 1 through 9, whatever. This gives me the dot product, this gives me the transpose, and then this gives me the inverse of a matrix, whatever this is. This doesn't have an inverse. I found that out this morning. Here's my pest parser generator. Love pest, reminds me a lot of Menhir from ocaml. But anyway, so we've got this stuff all set up. I'm not really going to go through this. If you guys want to learn more about the parser, you can go to my previous video. That has all the parsing stuff in it. Here is the parser again, right? As you can see, my AST node is either an integer, a double, monadic operation, or a dyadic operation, right? Monadic operation being like an inverse. It only takes 1 argument. Inverse, transpose, row reduced echelon form, rank, trace, determinant, etc. Dyadic operation would take 2 terms, so like the dot product, matrix addition. I don't really know what else. We have an assignment, right? So now, we have identifiers, matrices. So let's actually see what's being printed out here, right? We have our assignment from M to an expression, which is a matrix of integers 1 through 9, right? You can see that all the way over here. So now, when we go down here and we build the AST, we actually are making like a matrix from the AST nodes that are nested inside, which are really just integers. So like I construct a vector of integers, because a matrix in here is a set of terms separated by semicolons, and a terms is just one or more term, and a term is a decimal or integer, and an integer is any of these parsing things, right? The rules are kind of annoying, not annoying, I guess, just like deeply nested, right? So if you guys want to learn more about the parser, like I said, go see my other video. So after we get the abstract syntax tree root, which is really just a list, we then pass that into the interpreter. Okay, lala parser parse, get that result, put it into the interpreter. Let's comment this out. And the interpreter is what's actually going to be doing a lot of the cool work, right? So if we go down here to interp, first I should probably look into my lala type file. So here are my types. I actually had to make 2 new files just to make everything a little bit cleaner. I originally had this whole file and this whole file in interp.rs, because while I was live streaming, I didn't really care about making the code neat or look pretty. I just wanted to make it work on live stream while I was live streaming. So anyway, if I go in here for my types, right, I have 3 different types in my programming language, right? I have integers, doubles, or matrices. And now I had to, make a display trait for all the types, because when I print them out, like over here, when I print it out, because they're stored in an environment map, when I print them out, it has to have some kind of display trait. So, it's just pretty simple, right? You do the integer to string, write it to standard out, decimal to string. The only interesting thing was actually printing out the, what do you call it? Matrix, right? But other than that, it was pretty simple. Here's my matrix constructor, right? It takes in the whatever parser thing made, right? Which was a vector of AST nodes. And this actually creates the real matrix in memory. So, like how I had a list of AST nodes, which were integers, right? We just turn them into floats. Everything in the matrix is just going to be treated like a float. So that way, because if I do like the inverse, then it's suddenly going to all be like decimals, right? So I just want to make it always be decimals inside of a matrix. So this is what turns the AST node of a matrix into a actual matrix for us to use. And these are just some functions that are here to work with the matrix, right? So if I do, this is our matrix, right? It's a one-dimensional vector of float 64s. And then if I have these implications on the matrix, I have creating a new one. I have the dot product here. I have the row-reduced echelon form, which was really fun to program. I vividly remember doing this last January, or this past January, when I made my linear algebra library video, which I highly recommend you guys check out. I also have the cofactor function here, and I have the determinant function here. I have the transpose, the trace, the inverse. These are all really fun to program. This just creates an identity. I'm not really sure if I'm ever gonna use this. It actually modifies a matrix in place. I don't know why I decided to do that. That was pretty silly of me. Here I apply some function to every single element in the array. In the matrix. Here, combine, basically just, this can handle matrix addition, matrix subtraction, matrix multiplication, which is like not the dot product, element-wise multiplication, because I just pass in some kind of function. So this can be reused for a lot of things. Swap rows, I need this for my inverse functions and stuff like that, row reduced echelon forms, swapping rows. This just fixes some like float rounding errors, because I don't like seeing them. And then here was some cool things I had to do for the matrix. The index, and then the mutable index. This is pretty cool. But that's just like Rust stuff, which I don't really feel like talking about. Here we're doing actual programming language stuff. So we're back here in the interpreter. We're going to go through each node in the AST that was passed in here. Dereference it, right? Because it's a box, pointer, smart pointer, whatever they want to call it in Rust. And now it can either be an assignment, a monadic operation, a dyadic operation, or an identifier. Anything else, I just print invalid line and I print the line out. But for right now, all I really have is the assignment and the identifiers. For the monadic operation, the dyadic operation, I can take out a lot of stuff I used for the assignment match case and just like put it into a separate function and just call that. That's beside the point. I just wanted to say that's an easy fix. And the identifier, I just get it from my environment variable, whatever. Because we're in an interpreted language, all the variables are just going to be in a hash map. It's just going to be a map from the identifier, which is a string, to the lala type, which is either a matrix, integer, or a decimal. So we just get it, we unwrap it, we print it, and that's why I needed that display trait back then. So now when we go to eval assignment, right, this is a big function, right? What is this, 100 lines? Pretty much, 95. When I go to eval assignment, I'm assigning something, right, to a variable name. It's always let x equal something. Let x, which is the identifier, equal something, which is the expression. And obviously we will need to do some stuff in the environment. So now if I say, we have to dereference the expression because, like I said, it's a box. If it's an integer, whatever, I just insert it in. If it's a double, I just insert it in. If it's a matrix, I just put it in the environment again. Now, right, that was the easy part. Now it comes the monadic and dyadic operations. Let's start with dyadic over here. For the dot product, I match on the dot product, and now in this rule of the AST node, I have two things. I have a left-hand side and a right-hand side. If I go to my terminal and I look, okay, here's my thing. I have an assignment from x to the dyadic operation of the dot product between the left-hand side, which is a matrix M, and a right-hand side, which is a matrix N. Right? For right now, I'm just assuming that I'm always doing operations between identifiers. I obviously can just add another match case here where it's not an identifier, it's like a literal matrix, and I wouldn't have to get anything from an environment. I would just have to operate on the matrix directly. But for right now, for the dot product, I pull the left-hand side matrix out of the environment, right? So I get it out. It's a lala type matrix with the actual matrix inside. And so I pull out the M and assign it to left side. Right hand side, I do the same thing. And then I insert into the environment with the key, which is the identifier to string. And then I put in for the matrix the result of left side dot right side. I had to do this clone for some reason because it was giving me like a sharing permission or whatever issue. And that's pretty much it for the dot product, right? And it's going to be the exact same thing for plus and times. I can use that apply function that I was talking about before. Honestly, yeah, I could use the apply function for both of these, or it'd be lala type matrix, left-hand side dot apply, right-hand side, and then my function, right? Which would be like an anonymous function, x plus y, whatever. Like a lambda expression, I mean. If we go up here, into eval assignment again, and we look at our monadic operations. Again, all of these are following the same format. I'm just assuming that I'm always using identifiers here. Again, easy fix. I would just add another match case here. So like inside of these brackets, instead of having this underscore here, I'd add like a AST node matrix, and that's pretty much it. So now if we match on M, we get the identifier, we pull it out of the environment, we get the matrix. Then all we do is insert back into the environment a matrix, which is the inverse of M dot inverse. Row reduce echelon form, same exact thing, it's M dot RREF. Transpose, same exact thing. So now let's take a look at our example here. Let's clear this. Cargo run. Okay, let's take a look. When I do the dot product, I know this is correct, I looked it up. I closed the tab this morning and I don't want to retype the matrix right now. So when we do the dot product of M and N, these 3x3 matrices, it does give us this. When we do the transpose of this matrix, everything should be flipped along the diagonal, which it is. And then here we have Z, which is 4, 3, 1, 3, 2, 5, 6, 7, 2. Okay. And then A is the inverse. I'm going to assume that's right because my thing has always been correct with the inverses. So, yeah. That's pretty much it though. I mean, that's all I've been working on when I'm not like in school or doing anything else. Go on a live stream and just mess around with this for a little bit. If you guys like the video, I mean, all the code is on the screen. If you guys like the video, please leave a like. If you guys want to see more, consider subscribing, right? If I can reach 1,000 subscribers by the end of the semester, by like, not end of semester, I guess end of the year, right? December, whatever. That'd be pretty crazy. Because I started it over winter break last year, or early January, yeah. But yeah, that's pretty much it. I don't really have much else to add. Hope you guys enjoyed the video. Please put on notifications. See if you want to get in the live streams. Always have a few people stopping by. It's always fun. Talk about anything, really. I've talked about laptops with some people before because they want to know what laptop I was using. So yeah, I'll figure this stuff out with the plus and the times and, you know, not having identifiers always. But this project is looking almost complete now. If you guys want to see anything added to this, right? Like specific matrix things that you want to see added to this, please let me know. I don't really know what else to add. I think I could do SVD, but that's kind of hard actually. I don't know how to program getting the eigenvalues of a matrix. Maybe I'll do that over winter break when, you know, I have like a month to do nothing. But yeah. Thanks for watching the video, guys. And girls, if there are any watching. I feel like my target audience is mostly dudes. But yeah, have a nice one.